Hi, my name is Joe Sanderson. I'm going to briefly introduce myself, and then I'm going to go on to talk about a computer science topic that I find interesting. I worked as a developer for a little over 30 years. Very satisfying career. I loved solving problems. Worked with a lot of great people. About 2 years ago, I decided to look into nonprofit management. Got my master's degree at Muskie School, and I started volunteering in STEM programs around Portland. I'm currently the technical coordinator and reference librarian at MacArthur Public Library in Biddeford. So that's me. Let's move on to talk about an interesting problem. So the computer science topic I want to talk about is design patterns. The origins of design patterns go back to 1977 in the field of architecture. At that time, architect Christopher Alexander wrote a book called Pattern Language. And in this book, he proposed different solutions to various problems in the field of architecture. To give an example, a place to wait is a pattern that talks about solving the problem of people needing to wait and still have something to do while they're waiting, but be close enough that they can hear a signal that tells them that their wait is over. So some of the things he talks about are listed here, having a playground next to a pediatrics clinic, or the one that I particularly like, having a dark place and a glass of beer. That would be my ideal waiting room. So that got translated into software design about 20 years later when Ralph Emerson, John Vlasides, Eric Gamma, and Richard Helm, called the Gang of Four, wrote a book called Design Patterns, where they had proposed 23 different patterns that they broke up into 3 separate groups based on how the patterns work and what they do. So the pattern I'm going to focus on for the rest of this talk is creational, and it's called the Singleton. So a Singleton is a pattern where you want to only have one instance of a particular class that all users will get access to. So when would you want to use this? If you have a resource that you want to protect access to, such as a database or a logger, or there are a number of other examples which we'll get into when we get into some code. Let's look at a UML diagram for this. The key points here are that the constructor is private, so nobody can construct one of these objects the normal way. And then a public method which instantiates a new object which is stored as a static member. So that's the Singleton. Let's look at some code. So I'm using the Eclipse development environment. I'm going to start off by creating a Singleton class. I'll call it Singleton. And filling in the implementation here, it's got a private static member, which is the one instance of the Singleton. And it's got a private constructor. You'd also want to put in copy constructors here, but for the sake of time, I won't do that. Here's the public method that all callers will use. It instantiates the Singleton and returns it. And that's basically it. So then the next thing I'm going to do is create a test harness so that we can see that this thing actually works. I'll call it test harness. It's going to have a main because it's a main program. I create an instance of a Singleton by calling the getInstance method. And then I'm going to print out the hash value for this object so that when I get it again, we can verify that it has the same hash value. Here I'm going to get a second instance and copy and paste that and print out the hash value of the second instance. And let's see if it worked. I'll run this as a Java program, and there we can see the hash codes are the same. So let's have this do something more interesting. Most people are familiar with the Scrabble game. So I'm going to protect a set of Scrabble letters here with this Singleton class. So first I'll pop in the list of all the Scrabble letters, just as an array of strings. I'm going to manipulate that array to make it a little bit more useful by putting it into a linked list. I build the linked list here, create a new linked list, and then iterate over the first instance and copy all the letters in. And now when I instantiate the Singleton, I'm going to shuffle that list so that everybody doesn't just get A's and then B's. So then a corresponding update to the test harness to make this more interesting. I'm going to get the letter list, and then I'm going to get 7 tiles. I'm going to print out what tiles I got, and then the second player is going to create a Singleton instance. Second player is going to get 7 tiles. And what we're going to see, hopefully, is that they each get 7 tiles, and they're getting them from the same instance. So let's run this. Here's the results. Same instance. First player got EBIAI and corresponding, and then the second one got the letters after that, EIMOPC. So that's it. Thank you very much, and have a good day.